Just very briefly, about the Copernicus program. The Copernicus program is quite big. It consists of a space component, which are the Sentinel satellites, which some of you may know already or have worked with already. But then you also have 6 services, which provide more detailed or derived information about the atmosphere, climate, land, the marine environment, emergency management, as you've heard yesterday, and security. So quite a lot of data that are available through the Copernicus program, and the nice thing about it is that it's the data policy is a full, free, and open data access to nearly all of the Sentinel satellite data and the Copernicus service information to everyone globally. With regards to what can Copernicus do for marine environment or the maritime navigation, there are several applications, and here I've just listed some of them, which you can consider in maritime safety, search and rescue, navigation, law enforcement, together with GNSS or Galileo, providing a full set of information that can be used to manage safety at sea. For environment, there are also several applications on monitoring coastal zones to protect coastal areas, marine ecosystems near the coastline or farther out, to support the management of fisheries and aquaculture, to detect pollution and map the damage that could be done. Also for more commercial applications, infrastructure at sea, Copernicus has its applications in harbor monitoring, in renewable energy and finding the right locations for wind farms, for harvesting energy from sea, and to also support offshore activities with detailed information. So, as I've mentioned already, in Copernicus, you have the Sentinel satellites and the Copernicus services. Of particular interest for marine and maritime monitoring, I would say the most commonly used satellites are Sentinel-1, which is a SAR, or synthetic aperture radar sensor, which generally provides images with about 40-meter spatial resolution and 2 to 6 days revisit time. Sentinel-2 is then a more high-resolution multispectral optical sensor with a resolution of 10 to 20 meters in most of the wavelengths that it measures. While Sentinel-3 is dedicated to medium resolution imaging and altimetry, so looking more at really large scale processes at sea, sea level rise, large scale mapping of ocean areas, as it has a resolution of at least 300 meters. In terms of the Copernicus services, I will touch upon 2 services: the Copernicus Marine Environment Monitoring Service, which provides information, data, models about the physical state and biological dynamics of the oceans, both in Europe but also globally. And the Copernicus Security Service, which specifically has a maritime surveillance service managed by the European Maritime Safety Agency in Europe, with perhaps the disadvantage that this service is only available to restricted users that require access to that type of information. But I will show you also how to do or how to set up similar applications like that. So the Copernicus Marine Environment Monitoring Service, as I've mentioned, it looks at the physical state or the dynamics of the oceans, but more in particular, there are about 130 products in different families. So you have parameters, or it offers parameters that look more at sea surface temperature, salinity, waves and currents, and sea level. but also more towards the biological or biochemical side of things, providing information about turbidity, nutrients, chlorophyll, acidity, and perhaps less of direct importance to in ASEAN, also sea ice maps are provided by the Copernicus Marine Environment Monitoring Service. And all of those products are available at a higher spatial resolution in European basins, but also globally. You will find both analyses and forecasts at a very high update rate of about every 3 hours, I believe you will find a new product, as well as forecasts. I just want to briefly touch upon, for the people who want to use these data, they are available through the Copernicus Marine Environment Monitoring website at marine.copernicus.eu. So all of these data are there, are freely available. The only thing that will be requested is that you register to get access to the data, but as I've mentioned, they are freely available. And from there, you can really browse through all of the different data sets that are offered, have a look at some detailed documentation and metadata, and either look at them through a web viewer or download them mainly as .NET-CDF files, so for use in any kind of GIS system. And just to briefly show you what it looks like when you're looking at the web viewer itself, I just took an example from a product on significant height of sea surface waves, starting 3 days ago. So when it was an observation, and so every 3 hours it's updated. I've now taken every 24 hours. But with the added benefit that it immediately not only shows the observations, but also the forecast. So this is the forecast, and for today at 12 UTC. And this is something that could be very useful to get some very detailed and real-time or near real-time information about parameters at sea. The Copernicus Marine Safety Service, or Maritime Safety Service, is, as I've mentioned, it's a closed service within Europe for really restricted government users. But what it is that they do is they use synthetic aperture radar images to monitor or to do maritime surveillance, which entails both vessel detection and oil spill detection and monitoring. The reason why they use a SAR image is that it has the high reliability, because it can image in all kinds of weather. It can see through clouds, it can see in darkness. But also the information that you can obtain from a SAR image is very much tailored to detecting ships, as ships will be seen as very bright spots against a dark sea, while oil spills are darker areas against the waves of the sea, as you can see here in some of the examples. And within this Copernicus service, they use Sentinel-1, but also they combine it with other kinds of SAR images from RadarSat, as was shown already earlier. In the past, ERS, Envisat, Cosmos SkyMet has also been used for this purpose. So it's a service with the benefit that the Sentinel-1 data are freely available. And so if you would be interested in using Sentinel-1 data for ship detection or for oil spill detection, one of the things that is important to know is then also how often can you get one of those free images or free SAR images delivered to you. And the European Space Agency provides this revisit and coverage frequency map. So all of the tasking has already been planned well in advance, but still the images are taken so frequently that you will get a new image every 2 to 4 days in the ASEAN area. And just if you would like to start playing around with Sentinel data in general or Sentinel-1 data, you can obtain the images through the Copernicus Open Access Hub, where you can download them for free, again, after a short registration. And then it would be very easy to just draw an area of interest on a map, to look at the images that are offered, to request certain types of images, different processing levels. And if you're looking to automate this more, there's also an API available to automatically download or link to new acquisitions. In general, most new acquisitions are available on the Copernicus Open Access Hub within 3 to 24 hours. So also for operational applications, very useful to know that these are so rapidly made available. And then if you want to run a similar service, a good thing to know is that there is open source software available that provides these algorithms that to process SAR images and to detect either vessels or oil spills on them. For example, the SNAP toolbox from the European Space Agency is a very useful tool to start working with SAR images, as it provides specifically those algorithms, those state-of-the-art algorithms for object detection and for oil spill detection. I'll just very briefly end my presentation with some examples of potential applications in ASEAN countries. So with regards to maritime safety, as is everywhere the case, you have busy shipping lanes in this image around Singapore, and in many of the countries in the ASEAN region, you have large economic zones around your country. So that's a lot of area to monitor, and that's where the benefit of satellite images comes in, because they can be used to operationally monitor and figure out where things may require a little bit more detection or information, and where you can then send drones or planes to further analyze or check out what's going on with regards to an oil spill or some illegal or potentially illegal activity with fishing or with shipping. One other example that is shown here is the incident that just happened in the Suez Canal with the cargo ship Ever Given. And even there, using the free Sentinel images, which have a little bit of a lower resolution, about 40 by 40 meters, than the commercial SAR images, you can still use it to detect ships, in this case, ships that are waiting to enter the Suez Canal when things open up again. And then finally, more towards the marine environment monitoring applications. Water quality is one of the things that is often that often uses Sentinel-2 or Sentinel-3 data, depending on the resolution that is required. In this case, in the area of Port Klang in Malaysia, where you can see chlorophyll growth, which is caused by eutrophication from land runoff. Or using the wave information from the Copernicus Marine Environment Service, this could be useful for tracking plastic debris or other kinds of pollutions, and to see where things might potentially be heading to, so to do some damage prevention in advance. Thank you very much for your attention.